Amazing. So, hi everybody. Thanks for having me. This might be an odd place to start, but I want to start by reminding everyone of the moral foundations of capitalism. That we're all seeking a return for ourselves or our investors, and that's important. That's good. People's livelihoods depend on it. They'll retire better. But we're also allocating capital to productive things, and we're also creating confidence in the market, enabling other productive things to be funded. And that's why we live in an amazing world that is not like the Soviet Union, where they didn't have this tremendous engine of prosperity and confidence in the market. And so I guess I'm starting that way because I think it matters to be good at capitalism when we do it. And so as we're all making investment decisions, it's important to make wise ones and allocate capital to productive uses. So we've talked a handful of times in sporadic ways about cryptocurrency and blockchain today, and I'm going to spend the next little while talking about that also. I'm going to argue today that it is a crappy technology and a useless technology, and both specifically. In other words, the reason it is not being adopted is because it is bad for the things that it is purported to be useful for, and because it is bad for the things that it's purported to be useful for, it will continue to be non-adopted. And I think that that matters because if it is not a useful thing, then then it's a purely speculative asset, as I guess Howard was talking about before lunch. So I'm going to kind of launch through a bunch of things that people say that blockchain might be good for, and then kind of like discuss each of those in turn. Probably better to, well, gosh, if you want to like yell stuff out in the middle of the slides, you can heckle and boo and whatever, and I will either address in real time, or if you really stump me, I'll say, oh, no, in the interest of time, I need to keep moving along. So, blockchain. Some of you may have followed the technology more closely than others. Blockchain is a chain of blocks. It is a set of very small files that are linked together sequentially. So think of it as a database that you can only write on in one place. And it's very difficult to tamper with because each one is sequentially linked. That's what it is. A few things it is not. It is not a futuristic integrity wand. It is hard to tamper with, but that does not mean that all data entered into a blockchain is correct. It just means that it has not been tampered with since it's been entered. So this is one of those things where, it's sort of like important to distinguish that. It's also, people will say, we're going to do this on the blockchain. We're going to put it on the blockchain. The blockchain is not a thing that's out there, right? It's a literal data structure that exists on a set of computers. And so you can't say, oh, we'll put this on the blockchain and it can therefore, for example, never be deleted. It can be deleted the same as anything else on a hard drive if nobody saves it on their hard drive. So it's not like dust in the golden compass. It's a database. So each block in the chain contains data that links it to the previous file and sort of almost signs the previous file and certifies and seals it. And then you can put some new data in there, and then you're basically kind of guessing a bunch of random numbers. And so that's what you have about 450,000 computers doing at any given time, is guessing random numbers so that they can sign the previous block and add a new block. That's what it is. They say that there is a consensus algorithm. Typically, that's basically kind of a majority vote situation. And it takes that to edit past rows. You cannot edit past rows without a majority vote. If you do edit past rows, that's called a hard fork. It's hard to do. And that's kind of what makes it magical. People also talk about it as kind of inflation proof. But again, it's governed by majority vote. So if you think about, if you imagine that the Treasury started calling inflation, initial dollar offerings, like ICOs, that it's kind of like there's tons of new cryptocurrencies. People change the rules all the time. It's not tamper-proof in the way that you might think. Things that you wouldn't think that tamper-proof means what it does. It just means you can't edit past rows except by majority vote. Importantly, when you think about a private blockchain, what that would mean, for example, is that you are the majority if it's your blockchain, and so you can go back and edit past rows because it's yours. You're the majority. So this is kind of, but this is the point. It's hard to edit past rows. So what is it purported to be usable for? If you think about imagining it as a kind of futuristic integrity wand, I'm trying to get people to repeat that. That's a term I coined. Futuristic integrity wand. Anything that you want integrity for, you might think to do with blockchain. So money, banking, cards, voting, anti-corruption stuff, supply chain, escrow, stock trading, certifying that your handbag is really the handbag it's supposed to be, or that your diamonds are not blood diamonds. Smart dishwashers, football leagues. There was a football league that raised a ton of money, a startup football league where the fans get to vote, and they can vote on blockchain. So it's real. It has integrity. And my argument is that it is very useful for only the last three, art, illegal transactions, and as a Ponzi scheme, where you can put in some dollars, take more dollars out, and as long as people keep buying them, you keep on making money. Art I mean in the sense that this was, so I wrote an article that a few million people surprised me by reading, and somebody pointed out, I'd left out art in the original version. Somebody pointed out that you may believe that blockchain is inherently aesthetically valuable. So that's what I mean by art. If you believe that, then it has utility to you. But generally, illegal transactions in a Ponzi scheme are sort of like really the only things that I think may have some staying power here. Diving right in, banking. So the idea is, and this was sort of the first use case really widely talked about for blockchain, was that it was a stable store of value, right? So you think about it actually, in succession, each of the top Bitcoin exchanges have been drained of their funds, right? So you sort of think about, this is a purposely trustless and decentralized banking system where you're sort of responsible for your own security. There's no reversibility. And you sort of think, what does this look like, right? It's actually, we have a historical precedent for that. That's what banking was like in the Middle Ages. Each person was responsible for their own security. There was no sort of central authority enforcing the laws. And actually, the Knights Templar was a banking system. They were a very good way to deposit assets, make transactions across original borders, and they had lots of swords, and so they could keep your money safe. Modern banking is really kind of remarkable relative to this. So you think about, if, say, Wells Fargo had lost all of its consumer deposits, and then 2 years later, Bank of America lost all its customer deposits, and then a few years later, a third one fell. We would really be losing confidence in our banking system. And so as a banking system, this is like, it's like a new Titanic being launched every couple of years and sinking. It's really, really bad as banking. And it's built in, it's fundamental. The idea that it is purposely lawless and purposely irreversible. If somebody steals your Bitcoins, it is your fault on purpose. You should have taken better care. So if it wasn't for the asset appreciation, nobody would choose this as a way to bank, is my argument. Payments. The thing that, so irreversibility, again, is seen as a feature here, right? No trusted counterparty. But I would argue, just sort of very, very briefly, there's a lot of stuff about it being a complex form of payment, that it's slow, it's expensive. Actually, people are going through expensive trusted middlemen, right? So if you want to pay for something, you have to put money into your Bitcoin exchange, and then you have a wallet provider, and then there's an exchange, and but fundamentally, you're asking the end user to give up their frequent flyer miles in return for also losing the ability to dispute a transaction. it's just not a good deal. It's not something that anyone really wants. And in particular, people have talked about international payments where there isn't a trusted counterparty. Remarkably, Ripple does not use Ripple in its international payment system, which is just, it sort of blows my mind, because actually you think about, like, the CEO of Ripple was briefly the richest person in the world because of his holdings of Ripple. And so you think that that would be a really, really strong incentive to figure out a way to use these things to make international currency transfers. I mean, you imagine, like, suppose like a couple years in, Amazon said, actually, we're not using the internet to sell books. And it's like, it's just a bookstore then. Like, we have a name for this. It's a bookstore, right? And so they haven't figured out a way to use ripples. And so the way Swift works, briefly, and probably there are people in the room that understand Swift better than I do, so bear with me. But if you want to transfer money between two banks, you need to settle through correspondent banks. And Swift, the international wire transfer system, is a good way to search for a chain of correspondent banks such that I want to wire money to some provincial bank in Japan. The money gets moved from my bank to a dollar account somewhere in New York. That bank has a correspondent account with a bank in Tokyo. Dollars get deducted, yen get added, gets moved to the provincial bank in Japan and deposited for the end user. Ripple was supposed to cut out the middleman there. So it was like I could buy ripples, or my bank could buy ripples, and then the bank using yen could sell ripples, or vice versa, and then yen comes out the other side. The challenge is that actually nobody wants to own ripples, right? Especially if you're a big bank, right? The SWIFT network processes trillions of dollars. It's like the entire world GDP runs through that network every 6 weeks or something. I mean, it's just boatloads of money. And so if you imagine converting that all into something as unstable as cryptocurrency, where if you lose a password like, sort of Mt. Gox or Bitfinex or the other exchanges that get hacked, you can lose like a sizable percentage of the world's GDP in a single day based on a misplaced password, not to mention the sort of fluctuations inherent in cryptocurrency. And so actually, what's going to end up happening is that your correspondent banks on each side of the Pacific are going to very, very quickly try to get their money out of ripples. So you'll actually end up setting up the two Ripple gateways will want to move their money out of ripples into yen, and they'll actually end up keeping yen and dollar accounts. And so now you have I'm not explaining this well, but you end up with a 5-step process instead of a 4-step process, and everybody's like, okay, this all sounds good, but let's just take out the ripples. And so that's what they did. And people, it's good. It's like Swift. It's good. Okay, smart contracts. Smart contracts have gotten a lot of hype. You'll probably hear about this. I think it'll be the big thing after people give up on payments and banking, which I think is starting to happen. Smart contracts. The idea is that you can actually write software on blockchain, right? So Ethereum, for example, people will say this is very, very smart because it's completely programmable. It's a Turing-complete system for what it's worth. So this is the world's most prominent smart contract losing all its money. Sort of a theme. There was a thing called the DAO, which was designed to be a decentralized, autonomous organization where it was completely programmable by software, and all of the sort of expensive fund managers and attorneys and so on, I guess that's all of us, would be cut out because people could make investment decisions collectively but autonomously. So here's what happened. There was a bug that nobody noticed in probably the most carefully audited piece of software, one of the most carefully audited pieces of software in history, but it's complicated to audit software. And so somebody noticed a particular recursion issue and was able to transfer out all the money, i.e. invested in a small LLC in Estonia that had no business other than finding bugs in the DAO contract. So at this point, more than half of the Ethereums were stolen in the world, which is why the price dropped so much. And the point is people actually want to argue about what their contracts mean. So a contract that is effectuated by software is very different than a contract that is encoded in software. For example, when I buy an ebook on Amazon, I get the ebook. That's through software. I don't have a lawyer go over to Amazon to enforce the terms of service, but the terms of service that guarantee that I will get this ebook are written in legal language because that is easier to understand and easier to argue about than software. So nobody wants their contracts written in software. That's why that won't take off. In summary, supply chain. This is funny. It used to take 6 days, 18 hours, and 26 minutes for Walmart to figure out where its mangoes came from. This was a story that was very, very much tweeted. You can see that there were about 1,400 news articles that cited that particular number. And so this gentleman, Frank Yanis at Walmart, developed a blockchain-based system that could instantly, in 2.2 seconds, track the whole provenance chain of their mangoes. This is like it's a smart mango now. That's another thing I'm trying to coin, smart mangoes. So a couple observations. One, they had an RFID-based system that was supposed to create the same futuristic outcome. That was based on bananas. They had smart bananas in 2006 based on RFIDs. The challenge was that getting people to enter the data into their RFID-based tracking system was really hard. Nobody wanted to do it. And so they pulled the plug on it. It was very embarrassing in about 2010, which is why they had no system for tracking their mangoes, which is why it took so long, right? So this is this sort of like saying, let's take our sort of abandoned, mothballed mango tracking system, and instead of using our old database, let's put it in a very small, a long series of very small files, each one containing a hash of the previous file. It just totally fails to address the main issue, which is getting the accurate data into your database in the first place. So you think about this gentleman who is spraying I guess that's bananas with pesticides. Suppose it was a blockchain system that was tracking the provenance of these mangoes. What stops him from spraying the pesticides, right? It's just this sort of like, there's this theory that because it's on the blockchain, you couldn't possibly put false data on there, but actually it just totally fails to address the issue. It doesn't solve anyone's problem. Incidentally, a fun example of this, if you look at IBM, which is, I think, probably the top blockchain consultancy at this point, if you search for supply chain solutions at IBM, they do not mention blockchain. But if you search for blockchain solutions at IBM, they will tell you that this is a good way to do your supply chain. And this is sort of like classic blockchain stuff, right? That if you are looking for a solution to a problem in the real world, blockchain is not good at it. But if you are looking for something to apply blockchain to, everybody is happy to help you. Gosh, what's next? Escrow. So think about this, right? People have said a chain of provenance that is completely tamper-proof would be a great way to, for example, keep land titles, the title to your car, for example. So suppose your computer got hacked and the password was stolen, and somebody transferred the title to your car or your house to somebody else. That would be really, really bad, right? So think about like the DMV operating on the blockchain in this sort of irreversible world. And suppose for $10 a month more, you could upgrade to DMV Pro, in which you have to go into an office and present your driver's license in order for somebody to transfer your car title, right? That would be so good. Everybody would upgrade to the non-blockchain version that we have today, where it's really hard to steal the title to a car. I don't know if anyone's ever downloaded software that had a bug in it or a virus or something. But like if you lost your car every time you downloaded a virus, it'd be really bad. So yeah, I guess that's my comment on that. One other thing, domain names. People talk about this all the time, domain names, that you could resolve domain names with blockchain. And that's something that I had a moment of like, wait, maybe it's good for this. But you think about, again, this same problem with escrow. And there's so many situations where, so for example, North Korea hacked Sony, right? They didn't steal the domain names because Sony could just get them back, right? If we had a blockchain-based domain system, Sony.com would be pointing to whatever website the North Koreans picked today still, because why wouldn't they, right? So the fact that people don't really steal domain names is an artifact of this system that uses non-blockchain-based trusted systems. And it's the same, incidentally, for a friend of mine was running security for the German lottery. It turns out nobody tries to steal money from the German lottery because it's reversible, right? If you stole all the money, they would just move it back. So the best way to steal money from the German lottery is to fake the numbers and print yourself a winning ticket. And so that's what they're always trying to make sure nobody's able to do, is to take money from the lottery by printing a winning lottery ticket or making the lottery ticket you already have winning. But that's an amazing system. Like, we're so good at financial security because we don't use blockchain. This is three things in sequence. There was this amazing headline: world's first blockchain-powered elections just happened in Sierra Leone. The Sierra Leone Electoral Commission said, we are not using blockchain. And then the paper QZ.com issued a correction to clarify the extent to which blockchain was used. In other words, it was not used. So this is this sort of like milestone. And again, you sort of think about operating an election system is complicated, right? You have to register the voters. You have to make sure that one ballot or blockchain address is given to each individual, and that no ballot or blockchain address is given to somebody who is not an individual. And then you have to make sure that that individual, when they record an entry into your database, mark a ballot, enter a new blockchain thing, that the thing that they thought was going to happen is what actually happened, right? So you can look at a paper ballot, and you can see, I marked Donald Trump, I marked Hillary Clinton, and you look at it, and you see that your vote was accurately recorded. On a digital system, especially a blockchain system, who's going to tell you that your vote was accurately recorded? You know, in theory, maybe you're like sitting there at an iPad. Either you're trusting this app or you're trusting some third party. But the point is, it all runs on trusted parties anyway. And so when you think about trusted parties accurately counting votes, accurately building software, accurately registering people, making sure that the cronies of the ruling party don't intimidate people, don't mark 10,000 extra ballots and steal the election, how are they going to do this? Are they going to do this by carefully editing software to make sure that it doesn't have any bugs, or are they going to do it using the very, very good old-fashioned technologies? And you imagine this is a gentleman who had voted in the historic Iraqi elections. You imagine, how are you going to know that this guy voted or didn't vote? Are you going to audit the source code, or are you going to look at the ink on his finger, right? I mean, it's like, it's just really, really easy to count individuals as long as you don't use software. And then finally, there's this like TBD argument. This is one like particularly horrendous one. The most complex computing problem solved by humanity to date is how to target ads, which is like a little embarrassing, right? We spend more on that than like, solving the climate crisis or, searching for extraterrestrial life or whatever. It's all ad targeting, right? This is the biggest computing systems we have: Google, Facebook, Amazon, trying to figure out how to sell us stuff. Be that as it may, selling stuff is useful because that's what enables all of us to be here. It's a big computing problem, right? And so somebody who says, let's take the literal most inefficient computer system in history. It uses an amount of energy equal to the country of Denmark to store about 100 gigabytes of data. In other words, about 10% of what you could get for a $10 a month Dropbox Pro subscription. And let's use this to do the computing work that Google and Facebook have millions of servers. I mean, it's just like, it's mind-blowingly off base. But the point is, people will sort of say, well, what if the what if the use case just hasn't emerged yet? Isn't this kind of like the internet where kind of nobody knew what would happen when they invented TCP/IP? And who knows, right? But interestingly, on this first article that I wrote, somebody raised that, and there in the comments thread, one of the early internet pioneers chimed in and said, actually, when we built the internet, we built it because we wanted a better way to send messages and share files. And when we built the internet, it was a better way to send messages and share files, which is why we built it. We didn't know the scale or the impact it would have, but we didn't like build it for nothing, hoping that 10 years later somebody would come up with a use for this technology. That's just not actually how good technology evolves. And so there's a sort of fallacy that presumably, because it is useless to date, it is like the internet. Maybe most things that are useless end up becoming the internet. I don't know. Go over here. Then here's the argument: is that actually these problems are fundamental, right? That it's not just we haven't yet implemented it all the way. Adoption is slow. It's actually that the core theory underlying blockchain is that you can build a trustless world and eliminate middlemen, and that will create efficiency. That you don't need governance. And in fact, if you look at you have on the left, I guess here, Slush Pool is one of the 3 biggest Bitcoin mining operations. So about a little more than half of Bitcoin is mined by 3 organizations in China. This is what decentralization and democratization looks like. But you'll notice that they say long history of stable and accurate payouts. They don't say we use smart contracts to distribute your money. They say we have a long history. We're trustworthy. This is people sort of propping up institutions in a trustless world so that you have something to trust, which makes things so much more convenient. You look at Silk Road on the right. It's shut down by the feds, but it was an online Bitcoin-powered drug bazaar. You could buy heroin, LSD, cocaine, amphetamines, stolen credit card numbers, fake IDs. Hitmen were banned. You couldn't hire contract killers. The Bitcoin enabled you to hide it from the government, which is useful for doing something illegal. But what made it go was the seller rating system, right? That was how you could trust these, drug dealers to actually deliver the drugs. It was like eBay. And so it's just so sort of interesting because they set out to say, okay, we're going to eliminate the middlemen. And then the first large-scale application was somebody who managed to engineer a system to trust thieves using seller ratings, which is like institutions, right? It's just a very bad database. I was asked at one point this is when Kodak announced that it was using a new blockchain-based content distribution system. Somebody asked me, how would you build it? It turns out that when you are scraping content to identify fraud, or when you are searching licensable photographs so that you can actually sell this to people, you need very fast databases because you're writing actual software. And so you have blockchain maybe as a back office system connected to this. But it basically turns out in any sane implementation, if somebody tripped over a power cord and the blockchain got turned off, nobody would notice for a couple of days at least in terms of the operation of the system. It didn't provide any useful value to this or other companies. So punchline, you think about something that does not have utility, right? You think about tulip bulbs, for example. They grow into tulips. That's great, right? You could invest in tulip bulbs, and if nobody wanted to buy your stupid tulip bulbs, at least you get a field of tulips. Interestingly, almost everything that people invest in has some fundamental value, which is why it's better to own it than to not own it. And if nobody wants to buy it, then you get the use of it. And then you can sort of think of things in terms of there are user buyers in any market and reseller buyers, people who are hoping to sell it to some other user. And if there are no user buyers and only reseller buyers, that makes it a Ponzi scheme. And what makes blockchain so good at Ponzi schemes? I think the story is just that it sounds really futuristic. So if I said, for example, that this golden pyramid on the right has 289,080 pixels in it, if I offered to sell each of you one of those pixels for $10,000, say each, a steal, because there will never be any more of them. And so it's limited. It's like digital gold. You can't possibly produce more. It could only go up in value, right? The point is that's an obvious hoax. My argument is that that's what blockchain is. And yet you're seeing, after I published this article, my friends started sending me photos of stuff. Buy Bitcoin with your retirement savings. That's messy, right? There are real people that are going to be hit with this. The wealth coach, that was somebody, a friend of mine who was in South Africa. That was attached to a fence on a public park in South Africa. So that's somebody who is going to get, really, genuinely hurt. They don't have tons of spare income. It's not just a bunch of arrogant people in Silicon Valley who are going to lose out on this. And I guess I will leave it at that. Questions? Comments? Boos?
Hi. I had a U.S. attorney in Miami told me that he wanted to encourage as many international money launderers and criminals as possible to use blockchain, Bitcoin in particular, or any blockchain currency because he's found them so much easier to prosecute. So the chain of custody was there. It was incredibly easy. So there is one Bitcoin advocate, I think, that...
Yeah, right. It's sometimes not that good for illegal transactions or Ponzi schemes even. I was on a panel at the North American Securities Administrators Association, and they're very careful not to make news, but their observation about blockchain was we really wish we could get back to the things we used to do, but this is taking up a lot of our time. So no announcements of upcoming prosecutions or whatever, but they're spending a lot of time on it. Worth noting, something that people don't think about with ICOs, people will sort of say, well, if you're selling unregistered securities, that's creating a problem, right? But actually, so much of the infrastructure around registering securities, earnings calls, quiet periods, and so on, is actually to protect the purchasers and sellers from insider trading. And so if you are buying into ICOs that don't have regular earnings calls, quiet periods, don't file stuff with the public, if you know almost anything about why you're buying or selling it, which you may not, but if you do, you're probably engaged in insider trading.
Is Wikipedia blockchain? And is that a use?
No, it turns out that that the tamper-proofness of a distributed ledger is actually, it's usually not that valuable because it's easy to identify. The way you commit fraud is very rarely with recording the truth and then tampering with your records afterward. No, it's just, it runs on MySQL. A very traditional database. By the way, worth noting, ledgers are a truly transformative technology. And if the end result of the blockchain is that people invest a ton in better ledgers, there may be lots of use cases. So the Wikipedia running on MySQL is a great example of a great use of a ledger. Do I get to pick people? No, it's, I think, other people. Oh, hey.
Right now, a problem in currency transactions internationally is the exchange rate. You make the deal, but you don't get a final currency from either bank until it's over. Right. And often the surprise is an unpleasant one. I've wondered if the banks would co-opt the blockchain system in order to provide a better system for doing that so the rates would be guaranteed.
I think the short version is that using cryptocurrency to reduce currency rate volatility is it's much more volatile. So I think you would face in almost any implementation more volatility, but the thing one might hope for is that this creates emergent competitors maybe. So if there were more correspondent banks, for example, or if Ripple does become a competitor to Swift on its non-blockchain system, that maybe that will create faster clearing, for example, or more higher quality customer support around FX quoting.
Have you thought about how far away we might be from the computing power, at least, not being as much of an issue?
Yeah. So you can't. They have built faster ones. So one thing is the use of computing power is basically you're dividing up the proceeds every 10 minutes of recording the new transactions. And there's transaction fees, and so the more computing power you supply, the larger a chunk of the proceeds you get. If you move to a proof of stake system where you are, basically everybody is kind of like almost investing in creating the next transaction. So you can do it much more efficiently. There is a challenge that's sort of fundamental about sequential writes. That actually the first thing you do when you move past the sort of like 1960s database to the 1980s database is you do what's called sharding, which is basically enabling you to write in lots of different places on your database so that it's much more performant. So it will never catch up to a high quality database, but eventually that won't matter a ton. Go ahead.
Yeah, it sounds like a lot of the problems you brought up regarding blockchain and its use cases are related to people's private keys either getting hacked or misplaced. If we can find a solution to effectively and securely store those private keys, do you think these problems go away or are reduced?
Maybe. The thing that I've found is that almost always what you're trying to do is sort of you sort of like blow up your trusted institutions and then sort of figure out a way to kind of bolt on new trusted institutions on top of it. So you could say, what if some third party, your bank, for example, had your private key and it was only with them? And then what if they were insured by the federal government against loss of private keys? And then what if you sort of like set fire to the paper that had the private keys on it and just used ACH or Swift again? So you're sort of like moving back in a direction of establishing centralized systems that people can trust in. So I think you could make it substantially less bad. For example, you could say, much like multiply signed checks, you could say you have to have 3 different people approve, a wire transfer out of your bank account, and then that way, if your password gets stolen, you have 2 other family members. But isn't that just much less convenient? All
right. So the blockchain works because of complex cryptographic calculations. Quantum computing is supposedly around the corner, and they make cracking complex cryptographic equations kind of trivial. If quantum computing really comes to fruition, what happens to blockchain?
What happens to any of us? Yeah, it's actually sort of terrifying to think. There's a part of me that thinks that we're actually in a kind of golden age of cryptography, where PNP problems are basically. It used to be that codes, like you had like a secret cipher that was as easy to uncipher as it was to cipher, and so you had to keep it secret. And then there's been this sort of golden age where you could write a cipher and publish it, and it was very easy to validate that your cipher was correct, but that didn't mean you could crack it, right? So you think about like RSA or private key or PGP or so many of these standards that rely on particular classes of problems that get blown away by quantum computing. And so I think actually in 20 years, like the entire infrastructure of cryptography might get entirely blown up, and we will move back to people having like secret algorithms. I think it'll be, well, yeah, I think nothing will be the same. in terms of cryptography, including reliance on this stuff.
I've read articles that some countries in Latin America are already having problems with the weight of mining of cryptocurrency on the electrical grid. And this article said that at the current growth rate, the U.S. could experience grid problems by the end of 2019.
Yeah, so the challenge is, and again, this is like one of those things about the no fundamental value problem, right? You say, like, why is Bitcoin, which is basically a bad implementation of cryptocurrency because it's so costly to mine, why is it so much more valued? And you're kind of going down this rabbit hole if you say, why is 1 Ripple worth 2.5 stellars? Who would trade 2.5 stellars for a Ripple? A stellar is totally better than a Ripple, right? And I would challenge anyone to come up with a fundamental price for 1 Bitcoin, right? Why would it be 50,000? Why would it be 1 million? Or for any of these? So if we could give up on Bitcoin, so much of the problems on the grid would be solved, and everybody agrees that there are new ones that are better than Bitcoin. But again, because it's a Ponzi scheme, the fact that one is better technically than another doesn't have much to do with the values.